Alright, here we go again. Man, I'm making a lot of videos. Holy mackerel, I think we're going to add 5 this weekend. This is a review assignment for our Unit 9 test. I hope my pen's working with me. It doesn't look like it is. I always have problems at the beginning. I don't know why. I will try to get through this as quickly as possible. We have 30 questions to go over. My guess is going to take a little over an hour. God, I hope not, though, because 30 problems. Oh, my guys are going to be here all day. Okay, let's get going. Let's get moving. All right, as soon as I see this, I'm thinking, go over to my formula sheet, which I don't have open, which I should. Let me pop that open real quick. Bam. And there it is, formula sheet. So I look over here. Let's have those available to me. And I see my cosine A plus B formula. So there it is. Pop back to my worksheet. And I will say, okay, I remember that the cosine of A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. Now, you don't have to memorize these. You just have to know you have to go look for them. You're driving me crazy, kids. Go look for them. Parentheses, 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 minus, parentheses, 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 parentheses. The only thing I know, is that the sine of A is 4/5. That's it. That's all I was blessed with. I'm going to run with that. I know that A and B are in quadrants 2, so I'll draw me a triangle in quadrant 2. There's angle A. Sine of A is 4/5, 4 over 5. Now, I'm not going to do a lot of work. You should know that this is going to be 3. It's actually going to be negative 3 because it's in this negative direction. So the cosine of A, it's in the second quadrant, is negative 3 over 5. Shabam! All right, cosine of B. Boom. Go now. Same quadrant, angle B. We were given tangent. Tangent is opposite over hypotenuse, which in this case is negative 24. I'll do a little magic with my Pythagorean theorem. You have to do the Pythagorean theorem to find out that's 25. So now the cosine of B is negative 24 over 25. The sine of B is 7 over 25. And I typed this all in my calculator, and hopefully my calculator was correct. It told me my final answer is 44 over 125. That's it. We're done. Problem's over with. 1 down, lots more to go. 29 to go. Well, this one's not bad. We're just going to factor. I thought my next problem was kind of tough. Notice it says equal to 360, just in case. Just in case. So I got 2 cosine theta and cosine theta. I know these have to be both 1s. I just don't know which one's going to be which. Since I want them to add up to negative, I'll make this one a negative and I'll make this one a positive. When I solve this, I get cosine of theta equals negative 1/2. And when I solve this, I get cosine of theta equals 0. If I draw my picture, not 0, 1. Cosine of theta equals 1. When I draw my picture of my amazing cosine curve, it equals 1 here, and it equals 1 here. That's 0 and 360 degrees. Theta, I know that cosine equals 1/2, positive 1/2 at 60 degrees. I know that for a fact. So, it equals negative 1/2 in the second quadrant, which is 120 degrees, and in the fourth quadrant, which is 240 degrees. It equals 1 at 0 degrees and 360 degrees. There's those 4 answers. Done. Problem with number 2. Moving on. Write an equation of a cosine function whose maximum is 200 and minimum is 400 and whose period is 10 hours. Let's think about that for a second. Y equals A cosine bx plus c. They didn't say anything about a d. They didn't say anything about a phase shift, so I won't put c in there. The d part is going to come from these two. So basically what I have here is I have a cosine curve that starts high, comes down low, and goes back up high. So the minimum is 140. The maximum is 200. Now that difference is 60, which means it goes up 30 and it goes down 30, which means my amplitude is 30. So I got A. A wasn't a problem. A equals 30. So 30 cosine. Now, wait a second here. I just realized I made a mistake on my answer key, which is embarrassing. I should have a pen here available. That also gives me my midline. Wait. Write an equation whose maximum is 200, whose minimum is 400. Well, that means it's going to go right down the middle here between 200 and 400. That would be 170. So my plus D at the end here is 170. Now, I'm running out of room because I wrote so huge. So I'm going to get rid of all this stuff. You can bring it back just by backing up the video. Let's go back to drawing. Now, period is defined as 2 pi over b. And the only thing we got left to do is find out what b is. Well, they told us that the period is 10. Whatever 10 is, it's just 10. So 10 is equal to 2 pi over b. If I cross multiply, I get 10b equals 2 pi, or b equals 2 pi over 10, which reduces to pi over 5. So my final answer is 3 cosine pi over 5x plus 170. Problem 3 is done. That's 10% done. Woohoo! Uh-oh. All right, so let me get a color we can see here. And let's see. Here's my midline. I'm going to draw it in solidly just so you see it. There's my midline. All right. It's clear that I'm starting at a minimum. So let's see. How many full cosine curves do I get in there? That's 3 full cosine curves. 1, 2, 3 full cosine curves. So I know my frequency, which is B, is 3. Let's see. So we'll start out with y equals. My amplitude, it looks like it's going up 1 and down 1. So my amplitude is just 1. But I start at a minimum. So I want to start with negative cosine. I'm finishing 3 complete curves. So that's 3x. And I'm starting with a midline up 2. That's it. It's over. Oh, and it says right here, ooh, I forgot. It says, and determine the period. Determine the period. I didn't even see that. So I got to determine the period. Period is just equal to 2 pi over b. And in this case, isn't b 3? So this is 2 pi over 3. I don't know why I added that. It just did. Hint. Cosine of 285. So I've got to construct 285 degrees. So I'm going to say, all right, well, I know that's got to be 45 and something. I just don't know what that something is. Let's think. 45 plus, oh yeah, 240. And 240 is one of my nice angles. So I can bop over to my formula sheet. Oh, there's my cosine formula for adding 2 angles. Oh, we just did one like this. But the hard one, this is the easy one. Cosine 45 times cosine 240 minus sine of 45 times sine of 240. All right, that's it. I'm done. Well, no, not really. Let me grab a different color. All right, everybody knows the 45 is the square root of 2 over 2. Those ones we got committed to our memory bank. Boom, they're locked in there. This one's a little bit trickier, right? It's in the 3rd quadrant. It's down here, and it's 60 degrees away from 180. So our reference angle is 60. And I know the cosine of 60 is 1/2. But since I'm in the 3rd quadrant, it's negative 1/2. Minus, let's see, this one's also going to be negative. It's in that quadrant. But in this case, it's going to be negative radical 3 over 2. So let's see, this is going to be negative radical 2 over 4 when I multiply, minus negative radical 6 over 4. So my final answer I'll put it over here as -2, negative square root of 2 plus the square root of 6 all over 4. Kabam! Done. Moving on. Oh, yeah. I don't know if I left enough room for this one. See how we've got sine and cosine? Can't have a mix like that unless they have a GCF, which they don't. So that's not very useful. And so what we're going to do is we're going to replace this sine squared. Now you got to remember that sine squared plus cosine squared equals 1. So sine squared is 1 minus cosine squared. And that's what I'm going to replace it with. So 2 times 1 minus cosine squared theta. And then I'll just copy everything else down. Plus 5 cosine theta plus 5 equals 0. That seems rather odd. All right, so I'll distribute the 2, so I get 2 minus 2 cosine squared theta plus 5 cosine theta plus 5 equals 0. Now, since this is negative, everything has to go to the right side. I'm not going to show you how to bring things to the right side. You should be able to do this. We're going to have positive 2 cosine squared theta. When that 5 cosine theta comes over, it becomes negative 5 cosine theta. And then this is 2, and this is 5, so that makes 7, but when it comes over the other side, it's negative 7. I'm tired of blue. Let's try gray. I think this is gray. I wish they offered more colors. It would be fun to be more festive. So, 2 sets of parentheses. I'm going to factor this thing. I know it's got to be 2 cosine theta and cosine theta. And I know it's got to multiply to 7, get to 5. Let's not beat or belabor this to death. This is negative 7 and this is plus 1. Because that's going to give me minus 7 and positive 2, which is my negative 7. So here I get cosine of theta equals 7 over 2. And here I get cosine of theta equals negative 1. Well, I can't be bigger than 1, so that doesn't make sense. And when I draw my picture here, it equals negative 1 down here. That's halfway through the curve, which is at 180 degrees. Done. Next question. Find all possible values of theta less than 360 divided degrees that satisfy this equation. All right, so the problem is that cosine 2 theta. Now, if you remember, we go over to our formula sheet, I got 3 options: cosine, 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 cosine 2 theta. And since I have sine in the problem, I'm going to pick the one with sine. So I'm going to pick this one right here. Can you see this one I got my hand on? Right here. 1 minus 2 sine squared. So I'm going to replace it, 2. And then I'm going to copy everything else down. Minus 3 sine theta equals 1. I'm going to replace it. Let's go back and take a look. I'll see again. It's 1 minus 2 sine squared theta. So 1 minus 2 sine squared theta. So distribute 2 minus 4 sine squared theta minus 3 sine theta equals 1. Everything needs to go to the right side because my squared term is negative, so I'll put my 0 on the left. 4 sine squared theta plus 3 sine theta. Now when I bring this 2 over, I'm going to subtract 2, so I get minus 1. Oh, 1. I love when it's 1. It makes my life so easy. I would try 2 and 2, but with that thing being 1 and the middle term being 3, I'm going to try 4 sine theta and just sine theta. And I think most of you are going to see that this is a minus and this is a plus, because that gives me positive sine and this gives me negative 4 sine. This gives me sine theta equals negative 1/4, and this gives me sine theta equals 1. So when I do this in my calculator, I end up with theta equals, let me make sure, we'll do inverse sine of 1/4. So we'll go inverse sine of 1/4. I'm just doing 0.25. You get 14.477. And they said round to the nearest tenth of a degree. So 14.477. So theta equals 14.5. Now, since this is negative, I cannot keep that answer. So I'm going to add 180 to it. So that's 194.5. And I'm also going to subtract it from 360 degrees, which gives me wow, I just made a mistake. Ha ha, Jess, you aren't going to find it. I'll tell you what, I'll leave it there. Found a mistake. You find it. Sure, there's a mistake. Nah, I'm gonna find it. I'm gonna keep it. I don't want you guys to get bonus points. I'm tired of you guys getting bonus points. You guys, plenty of bonus on this test that I know you guys can do. So we're gonna keep it. So let's go back. See if I can highlight my mistake. You see, I put a +3 here, and then when I came over here, I said these two make negative. These two on the outside make -4, and these two on the inside make +1. Well, that adds up to -3. I need them to add up to +3. So I made a little bit of mistake. I'll change it in black. Black meaning, oh, I'm so embarrassed. So this should be the negative, and this should be the positive, which means this should be negative, which means this should be positive. Therefore, having said all that, I am going to keep 14.5 degrees. It's a great answer. I love it. So my three answers are going to be 14.5, 165.5 degrees, and let's see, drawing my sine curve, it equals, oh yeah, -1 down here at 270 degrees. And there we go, 7 problems done. On to number 8. Oh, this looks like a lot of fun. This is really the same as cosine of 1/2 of theta. Going over to look at my formula sheet. I'll get there eventually. There it is. Cosine adds. And all we need is to know what cosine is. Let's see if we know that. Oh my gosh, they're so nice to me. Plus or minus 1 plus cosine of A, in this case theta, all over 2. Which is equal to plus or minus 1 plus parentheses -7 over 25 all over 2. Now, because I know so many of you are having problems with this, I'm going to show you how to do this on the calculator one last time. You have to start with a fraction. And we're going to do 1 plus. Use parentheses to substitute in. And then we do another fraction, control division. -7 over, I think it was 25. 25 all over 2. Now when you're done, it should look like what you have written there. Hopefully it does. Get 9 over 25. That's nice. That we can deal with. So this is plus or minus the square root of 9 over 25, which is equal to plus or minus 3/5. Now we have to decide, are we going to keep the plus or we're going to keep the minus? We've got some issues. We're in the fourth quadrant. All right, any angle in the fourth quadrant is going to be between 270 and 360. If you cut that in half, guaranteed it's over here somewhere. So we need to keep the negative. So our answer is -3 over 5. And that would be our answer. All right, kids, moving on. All right, mins and max. I'll do both. I'll do max and I'll do min. But notice that we're looking just for the min. If you remember, it's d plus the amplitude, d minus the amplitude. Now, I tried to trick you a little bit by making that number out front a negative, but that's not the amplitude. So we'll take the d, which is 1.5, and we'll add on the amplitude, 4. That's 5.5. Or we'll take the amplitude and subtract off, we'll take off the d or the midline and subtract off the amplitude. Oh, man. I did that backwards. And I get -2.5. And there's my answer right there, negative 2.5. Find the event. Now we're given cosine, right? And remember, there are three versions of the cosine 2x formula. There's the one with cosine and sine, which you almost never use, the one with cosine, and the one with sine. And since we were given sine, we're going to use the one with sine. So the cosine of 2x equals 1 minus 2 sine, oh, my laundry's done, times squared of x. Or this is equal to 1 minus 2 times negative 10 over 12 squared. Well, I'm just going to type that in my calculator. I'm not really sure what it is. It's 1 minus parenthesis. I forgot the 2. 2. And then we need a fraction, so control division. Negative 10 over, was it 12? Oh, forgot the square. Doggone it. Got to go back. Hit this, enter. Put a parenthesis here. And we forgot to square this thing. Makes a huge difference when you don't square this thing, doesn't it? Just a simple little thing. 8/3, and now we got, negative 7 over 18. And that's what my answer key says, so that's good. Negative 7 over 18. Don't miss things. Don't miss things. Moving on. Oh, man. So here's what we're going to do. We're going to treat these as two different functions. I'm going to treat this one as the, no, I'm not going to use blue because blue won't show up here. I'm going to use this one as the green or the red. That's the most complicated one. And I'm going to do this one as another separate function. So I'm going to just draw in the line y equals negative 1. So I'm going to draw that in. There's the line y equals negative 1. So we want to see how many times over this thing will this thing hit it. All right, so let's see. Let's work with, oh man, I said I was going to use red and I changed up on you, so let's do this. Let's change this to green. We'll do this one in green. All right, so my amplitude is 1.5. My period is 2. My scale, my frequency is 2. My period is pi, because that's 2 pi over 2. My scale, well, the scale's already there, so I'm not going to bother putting that on there. I don't have a C and I don't have a midline, so it's going to start right at the beginning. Now we start at a negative 1.5, so we're going to start down here. Now every pi is a new maximum. A new maximum. Now remember, this line I drew, I shouldn't have drawn this in a dotted line because you're probably wondering why. This line I drew is just the line y equals, well, it should equal y equals negative 1. That's not my midline. My midline for this thing, the green curve is really what we're graphing is y equals negative 1.5 cosine 2x. That's what we're graphing. So this one doesn't have a midline, or its midline is right here. We're going to go right along the x-axis. So down 1.5, we're going to go up 1.5 in the middle. So this is the green curve. And another maximum at 2 pi, and another minimum at 2 pi, and another maximum in between those. Sorry about my lousy drawings. So the question says, how many times do they hit? 1, 2, 3, 4. There's the answer. That's kind of a tricky one. Kind of fun. All right, so let's solve this. So we get negative square root of 2 secant equals 2. Well, just solve for secant. Oh, secant of x. Forgot the x. So divide by negative square root of 2. Divide by negative square root of 2. And I get secant x equals 2 over, well, I can't put the negative down there. I'll just do that. All right, so there's two ways to solve this one. The easy way is to realize that secant is really 1 over cosine of x. And that's equal to negative 2 over square root of what you have here. So if I flip both of these, what I end up with is cosine of x equals negative square root of 2 over 2. And we know that x then is a 45-degree angle. But I don't have to do that. And if you didn't see this, then you may not have done this. You know, pause it right now if you want to look at it, because I'm going to erase it. So what I would suggest you do is just come over here and just do, we're going to do the inverse secant of 2 divided by, notice I'm not putting the negative in, radical 2. And look, 45 degrees. That's, you know, that's what we just already determined, 45 degrees. So in this case, theta, or x, is equal to 45 degrees. Now, it's negative, so that puts us in quadrants 2 and 3. And in quadrant 2, 180 minus 45 is 135. And in the third quadrant, it's 180 plus 45 degrees, which is 225 degrees. All right, here we go again. We got a mix of sine and cosine. I'm going to replace this sine squared theta with 1 minus cosine squared theta. And I'll copy everything else down. Minus 9 cosine theta minus 3 equals 0. Now my pen's too fat, so stop doing that. 5 minus 5 cosine squared theta minus 9 cosine theta minus 3 equals 0. Anybody bored? I am. Kite, you find any mistakes yet? I know you always find mistakes. You're relentless. I got a bunch of kids that find mistakes, but you're like the most relentless. You like love to find my mistakes and just torture me. All of this stuff needs to go to the right side. So I'm going to make this 5 cosine squared theta. When this one goes over, it becomes positive 9 cosine theta. And let's see if I can not screw this up. 5 minus 3 is positive 2, but when it comes to the right side, it becomes negative 2. Factoring doesn't look too bad, because 5 times 2 is 10, and that's really close to 9. So 5 cosine theta and cosine theta. And I'll put the 2 here and the 1 here. This is going to be minus. This will be plus. Alrighty. So I end up with cosine theta equals 1/5. And cosine theta equals crapola. It's negative 2. It can't be negative 2. We cross that off. When I do the inverse cosine of 1/5, I end up with theta equal to 78.46304. Round to the nearest tenth of a degree, I get theta equals 78.5. All right, so my two answers. Yes, I'm going to keep this one, 78.5. And then where else is cosine positive? Cosine is positive in the fourth quadrant, so I'm going to take 360 and subtract off 78.5, which I will do on my calculator. 360 minus 78.5, 281.5. 281.5. Another mistake on my answer key over here. Man. That's what happens when you do math 24/7 on the weekends, especially. We're almost halfway there, kids. Let's see. The Sea Dragon pendulum at amusement ride moves from its center position, resting according to this pendulum, where T represents time in seconds. How many seconds does it take for the pendulum to complete one full cycle? Now, you should know that one full cycle really means, okay, what's the period? That's all we're looking for. What's the period? And I know that to be 2 pi over b. And if I look, there's b. And that's why this problem's complicated, because I got a weird b. Sort of like some of my students. There's my b. So now I've got a number divided by a fraction. So what we'll do is we'll flip and multiply. So this really becomes 2 pi over 1 times 3 over pi. Pi's cancel, and my answer is simply 6. Done. Almost finished. Let's see what this next one's going to look like. Oh, this looks like fun. All right, I don't know if that matters. We're going to find cosine of 2a. Now, I was given sine, so I want to use that double angle formula that only has sine, and that's 1 minus 2 sine squared A. Or 1 minus 2, and then this thing squared, and that thing would be radical 5 over 3. And this one can be typed into your calculator because you have a radical squared. So let's see how we do it. 1 minus parenthesis, and then it's the square root of 3. I should have made that a fraction. Control division. Divided by 5? Is that what it is? Oh, is it 5 over 3? Square root of 5 over 3. Good thing I looked. Square root of 5. Otherwise, Miss Kite would have been jumping on me like, hey, Mr. Graduate. Just kidding, Jess. I love the fact you guys find mistakes. You're not the only one. There's a lot of people. I just like to pick on you. But I did forget the 2 again. You were hoping. You were like, man, he forgot the 2. I'm going to find. Oh, man. What is that thing? Man, that's not very nice. That's not going to, now I know what that is. I hope you do. I will teach you something at the end of this, but that's not going to help us out. So what we got to do is 1 minus 2, and this thing would be 5 over 9. And then if I did that, that'd be 1 minus 10 over 9. And then if I did this as 9 over 9 minus 10 over 9, I get negative 1/9. And there's your answer. And just so you know, anytime you get repeating numbers like that, 0.111111111, that's over 9. If you get 0.25, 0.25, 0.25, 0.25, that's 25 over 99. So anytime you get multiply numbers like that, it's always either over 9 or 99 or something like that. Halfway through, kids. All right, 16 is sort of going to be bonus on the test on Friday. So it is not something I've taught because we ran out of time, but it's not that bad. So I'll go through the answer. You got a force of 20 pounds and a force of 15 pounds acting on some body, not a person body, just something. So we'll make this to 15 and we'll make this to 20. And it says that the resultant force is 19 pounds. It says find to the nearest degree the angle between the two original forces. So what I really want to find is this one, but I cannot find that one directly. I have to use a property of parallelograms that say that any two angles in a parallelogram add up to 180 degrees. So what I'm going to do is find this one. And then when I got that one, I can find this one. So this is 15. And we use the law of sines here because we have side, side, side. And I'm looking for an angle. I'm looking for this. I'll call this x and this x. And I'll just use a and b for the other two, just for fun. So x squared is equal to a squared plus b squared minus 2ab cosine of x. If you want to call them c, call them c. I don't really care. Since we have to find an angle, just like we did with all the law of cosines, we're going to isolate the cosine of x. So x squared minus a squared minus b squared all over negative 2a. I don't know why I use b. This should be b. ab equals cosine of x. All right. Now, cosine of x is equal to 19 squared minus 15 squared minus 20 squared all over negative 2 times 15 times 20. And when I do that, and then immediately I'm going to do the inverse cosine of this thing. And when I do that, I get x equal to 63.896. Sorry, I'm trying to save time. Might run out of memory. So x equals, rounded to the nearest what degree? 63. So this is 64 degrees. So even though my picture doesn't show it, this angle here is 64 degrees. Which means this angle is 180 minus 64, which is 116. And there's your answer. Triangular plot of land. He measures the form of two sides and the length of 400 and 200, and the included angle to be 50. What is the measure of the third side of the plot of land? So we got a triangular plot of land. Just for fun, we'll call it A, B, and C. I don't know why. One of the lengths is 400. One of the lengths is 200. They said the included angle was 50. and they want to know what is the third side. So, law of cosine, classic law of cosines. We have a side, angle, side, sassy. A squared equals b squared plus c squared minus 2bc times cosine of a. And I get a squared equals 400 squared plus 200 squared minus 2 times 400 times 200 times the cosine of a. I think my computer is running out of memory. I'm going to have to check. I am going to save myself some time. I get a squared equals 97,153.98245. I take the square root of both sides and I find a equals, when we're all said and done, 312. Moving and grooving. 18. All right, I think we do law of sines a couple times here, right? All right, so triangle again. Plots of land are 50, 80, and 100, and it wants to know the degree of the largest angle. The largest angle is always opposite the largest side. So we are going to use, let's call this A and B and C, and we will do a squared is equal to b squared plus c squared minus 2bc cosine a. Now, I'm looking for an angle, so I'm going to isolate the angle. We've done this a million times. A squared minus b squared minus c squared all over negative 2bc. That's what cosine A is equal to. All right, so cosine A, if I substitute everything in, is equal to, let's see, 100 squared minus 50 squared minus 80 squared all over negative 2 times 50 times 80. And I get cosine of A equals. Now I'll type this in for you just for fun. Do control division. And it is 100 squared minus 50 squared minus 80 squared all over negative 2 times 50 times 80, and you get negative 11 over 80. So you get cosine A equals negative 11 over 80. What that just means, it's going to be larger than 90 degrees, not a lot larger. It's negative, and then we'll do the inverse cosine of this. So trig inverse cosine of that answer, and we get 97.9 degrees. Round to the nearest degree, we get 98 degrees. Now, the last thing this thing says is find the area of this triangle to the nearest square meter. So we're going to use that angle that we just found. Now, they told us to round it, so we'll use its rounded form. And I'm going to do this very carefully right here. A equals 1/2 50 times 80 times the angle in between, which is sine of 98. So I did not do this on my other answer key, so I got to do this here. So 0.5 times 50 times 80 times the sine, and I'll just do it. It never really makes too much difference of that. 1981. And my answer for the area is 1981. All right, so this one should be pretty easy. Divide by 5, divide by 5, and I get secant theta equals 8 over 5. Well, that's not a problem. I just do inverse secant, and I end up with theta equals 51.317, or theta equals 51 to the nearest degree. Secant is positive in the first, so it's 51. And the fourth, and so we subtract from 360 and we get, what, 309? All right, that was quick. All right, so I got to replace this cosine 2 theta. I'm going to replace it with something that has cosine in it. So it's 3. Let's see, that's 2 cosine squared theta minus 1 plus 17 cosine theta equals 0. Distribute, I get 6 cosine squared theta minus 3 plus 17 cosine theta equals 0. Since this is positive, we'll leave it here. So 6 cosine squared theta plus 17 cosine theta plus minus 3 equals 0. And then this factoring is actually quite easy, only because 3 times 6 is 18. So 6 cosine theta and cosine theta. And then this one's going to be plus 3 and minus 1. Correct? All right, so this one's going to give me cosine equals negative 3. That's garbage. And this one gives me cosine theta equals 1 over 6, or theta is equal to, if you round it, when you do the inverse, you get 80 degrees. And so cosine is positive in the first, so it's 80, and positive in the fourth. 360 minus 80 is 280. That's weird. What is the period? Okay, period is defined as 2 pi over b. b is pi over 8. So it's really 2 pi over 8, which means we're going to flip and multiply. So 2 pi over 1 times 8 over pi. Pi's cancel. My period is 16. Done. Find the exact value of cosine 165. So this is cosine of 45 plus 120. So that's equal to the cosine of 45 times the cosine of 120 minus the sine of 45. My pen's guy, and that's why I got to keep going, times the sine of 120. All right. This is what happens when you run out of memory in your computer. It starts to not act right. This is the square root of 2 over 2. And it's the, cosine of 120. Reference angle is 60. It's in the second quadrant. I know the cosine of 60 is negative 1/2. This is the square root of 2 over 2. Sine of 120 is the square root of 3 over 2, even in the second quadrant. Come on, man. So you guys know that. So this is negative radical 2 over 4 minus radical 6 over 4, which gives me negative radical 2 minus radical 6 all over 4. Hopefully I got that right. Woo! 8 left, kids. 8 problems left. Oh, and then we got this hard one. Oh, man. These look tough. We'll do this one. So A is 1. B is 2. My period is pi. My scale is pi over 4. Did they give us the scale on this one? Oh, they gave us the scale on this one. So we're going to have to do something a little bit differently. Min and max is going to be 1 and negative 1. That's no big deal. Let's do this one in red. Amplitude is 4. My period is 1. My B is 1. So my period is 2 pi. And I can't really do the x scale, and there's no thing. So let's do the green one first. Now the green one should have scale markers at pi over 4, which is here, 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 and here, and here, and here, and here, and here, in between all these. So It starts with a negative and it goes up and down 1. So it starts with negative 1. It has a period of pi. So at pi, it will be back at a minimum. And at another pi, it'll be back at a minimum. And in between those, it's at a maximum. So here's another pi. Here's another pi. In between those, we're at a maximum. So this is going to look like, sorry, this is going to be awful. In between each one of those is 0, so that's why I'm going to try to hit those tick marks. All right, switch to green. Now green doesn't move up or down. It's basically just it's got an amplitude of 4, but it's going to finish a full sine curve in 2 pi. So it means it's going to start here at 2 pi. In the middle, it'll be at 0, and at the end, it'll be at 2 pi. So remember, the zeros are every other one. Zeros are every other one. All right, it's going up 4, so in between, it'll go up to 4. And down below, it'll go down to 4. And down here, it'll go down to 4. And then up to 4. So this one should look like something. Oops, that looks like crap. What did I do? All right, let's try this again. In between these two should be a minimum. In between these two should be a maximum. So let's try that again. Oh, much better, much better. There we go. Hit that point. I don't know what I was thinking. All right, on this thing, it's almost impossible to hit those things. Anybody turn in something like that, Neely, and you are in trouble. How many times did it hit? Once, twice, 3 times, and it hits 4 times. So the answer to this question is 4. And the way my pen's acting, it's even worse. All right, let's move on. So what we're going to do is we're going to make this 12 cosine theta minus 5 over 1 equals 3 over secant theta. Remember, it's just it's really 3 times 1 over cosine, which really just makes it 3 over secant, or not 3 over secant, excuse me, not 3 over secant, 3 over cosine. And then we'll cross multiply, so we get 12 cosine squared theta minus 5 cosine theta equals 3. Bring the 3 over. Minus 5 cosine theta minus 3 equals 0. We will factor this bad boy. Let's try 4 cosine theta and 3 cosine theta. And then we probably should be doing, this should be negative 3. And this will be positive 1. That will give me my negative 5. So I get cosine theta equals 3 over 4. And I get cosine theta equals negative 1/3. The only hard part about this one is, for the one that's 3/4, I get theta equals 41.4096. So if you got that, great job. If you have a calculator that can do degrees, minutes, second, I set to the nearest minute on this one, so it's 41 degrees. Oh, nearest minute, and I rounded to the nearest second, so that's going to be 25. Why did I do that? I rounded these things to the nearest second, and they should be rounded to the nearest minute. So there's the nearest minute. So we have to include that one. So 2 of my answers are going to be 41 degrees, 25 minutes. And my other one's going to be where cosine is positive in the 4th quadrant, and that would be 318 degrees, 35 minutes. And then this one, where it's negative 1/3, sorry, that's a 1/3. and I do inverse cosine on that, I get 70.528. So we got that. Great job. Theta equals 70 degrees and 32 minutes. So that is not one of my answers. So I have to subtract that from 180. So I get 109 degrees. That doesn't make any sense. 109.28. Oh yeah, 109.28 degrees or minutes. And the other one is adding to 180, and I get 200. I didn't write this down right. 50 degrees and 32 minutes. Woo! That's a tough one. Hopefully not. I don't have any more hard ones like that. All right, so 25 is another one of the bonus questions, another one of those forced questions that you don't necessarily have to do. All right, I'm back. I don't know where things ended, so I think things are going to run hopefully a little bit smoother now. If you know anything about computers, you can only store so much video memory and RAM, and then you start running out of space and the computer starts dying on you. So in this case, I got a 1,500 pound force. Oh, that doesn't look too good. And a 2,000 pound force. I wonder if we're running out of just hard drive space now. And my resultant is 3,000. Time to clear some stuff off my computer. That's for sure. So, what do I want to do? Well, this is 1,500. Let's start with that. And then what's the question says? Find the angle between the two applied forces. So really what they're looking for is this angle. I think we've talked about this. No, we haven't talked about this before, but if you've done the video with the forces video, you'll find out that you don't find that when you actually find this angle right here. So I'll call this X and I'll call this X. And so what we're going to do, this is classic side, side, side. So I will do x squared equals a squared plus b squared minus 2ab cosine of x. Well, since I need to find x, I need to isolate that. So I'm going to do x squared minus a squared minus b squared. This is not helping very much. I thought it would help over negative 2bc. And that's equal to cosine of x. All right, we're getting there. Hopefully we'll get this. We'll get 3,000 minus 3,000 squared minus 1,500 squared minus 2,000 squared all over negative 2 times 1,500 times, oh my God, I'm sorry about this, guys, over 2,000. This is just depressing. I think the computer's as tired as I am, is equal to, where am I at? Equal to cosine of x. Let me try to speed things up a little bit. I'm sorry. We're going to do the inverse cosine of that mess, and you're going to get x equal to 117 degrees, point something, 0.2796 degrees, and I want it rounded to the nearest degree. So this angle would be 117. And to find the other one, you just take 180 and you subtract off 117 and you get 63 degrees. 63 degrees. So that's the answer to that question. I don't actually have an answer key for the rest of them because they're problems I added on later. I just want to make sure, because they are going to be on the test, I want to make sure you know how to do these. So my A equals 3, my B equals 2, my period is pi, my scale is going to be pi over 4, my C is pi over 4, and my D is 2. My min will be 2 minus 3 or negative 1, and 2 plus 3 for my max, and that would be 5. And my starting point is pi over 4, comma, a minimum, which would be negative 1. And it's a minimum because this is negative. So this is pi over 4, pi over 2. Since I'm having a hard time writing, I'm not going to write them all. 3 pi over 4 and pi. No, that's pi over 4 to pi over 2. This is pi 5 pi over 4, 6 pi over 4, which is 3 pi over 2. And then this would be 2 pi. Now I'm having a hard time writing, so this is negative pi over 2. This is negative pi. Oh, my pen is going crazy. This is negative 3 pi over 2 and negative 2 pi. All right. Oh. Now let me draw that midline in before I forget about it. It's at, my midline is at positive 2. So there's my dotted midline. Oh, nice and neat. It's so difficult to draw on this tablet, kid. You have no idea. You got it easy. Man, it's hard. All right, so let's see. My starting point is, be careful here, pi over 4, negative 1. That's my starting point. Now, my period is pi. So every pi normally would be here to here. But I don't want to go there. I want to go a little bit past there. And normally then it would be here, but I want to go a little bit past there. Now, I'm not going to plot that point. I'm not going to graph that point, but I want to see it just so I have it. Now, in between each of these, halfway in between each of these, I'll have a maximum, which is 5. Oh, I didn't put a scale. 1, 2, 3, 4. This will be 5. So in between each of these, I'll be at a maximum. And then let's see, I'm going here. Wait, normally pi would be, how many are you going to count? 1, 2, 3, 4. 1, 2, 3, 4. There it goes. 1, 2, 3, 4. There it is. And in between each of those, I'll have a maximum. And I'd have another maximum over here somewhere. All right, so sorry. All right, I would not accept this on a test. I literally cannot. Not only the pen's dying, I just cannot seem. It's not supposed to be the way that looks like. All right, because in between each of these should be 0. So that should be on a 0. That should be on a 0. That should be on a 0. A 0. This should be over here. This should be over here. This one is so far off. Look, it should be there. So anyway, that's that one. Sorry about that, kids. We're getting there. I think I got one more to do. So I'm going to just put the scale. Let's see. The scale is going to be the same. Pi over 2. Pi. 3 pi over 2. And 2 pi. Pi. Negative 2 pi. I wonder why I picked both of these to be negative. Oh, they're the exact same thing. I didn't change anything. Oh my God. So I'm going to change this right now. We're going to make this 2. We're going to make this 1. And we're going to make this minus pi. Actually, we're going to make it plus pi. So that makes A equal to 2, B equal to 1, the period equal to 2 pi. I've got my scale already on there. Scale is pi over 2. Our C value is negative pi. Our D value is, let's do positive 2. Let's do minus 3. Minus 3. My starting point is negative pi. Oh, and I didn't do max or min. Max is going to be 2 minus 3, which is, no, 2 plus, what the hell am I doing? Negative 3 plus 2, which is negative 1. And that's the max. And the minimum is going to be negative 3 minus 2, which is negative 5. God bless it. This pen is driving me crazy. So because it's a positive 2, I'm going to start at a maximum. Maximum is negative 1. So let me get my midline in. My midline is at negative 3. Here's my midline. And I'm going to start at this point right here. Negative pi, negative 1, right there. Now, every 2 pi is a maximum. So this is 1 pi, here's 2 pi. There's 2 pi away. In between those will be a minimum. So this graph would look something like this, because in between each of those is a 0. So pi I went over too far. Wait, this should be 3 pi over 2. And this should be negative 2 pi. I was rushing. This should be a 0. And this should be down here at a minimum. So it should be like this. And then this should be a 0. And this should be a minimum. And it should go like this. Alright. Woo! I think we got 2 left. 3 left. Oh, good. We ended with a couple easy ones. So this, with a minus in the middle, is the plus formula. So this is cosine of x plus y, or a plus b. So this is 100 plus 40, which is 140. Cosine 140. This is the minus formula. So this is cosine of 190 minus 35, which is, oh, no. I lied like a dog. Yeah, this one's plus. This one's minus, so it goes to plus. This one's plus, so it goes to minus. And this is not what I wanted here. I got to change this. Oh, I got to change this. So probably before you get it, these will be set. I think I did these backwards. So let me do these backwards. I'm going to switch both of these on the practice test, so you're going to see this. You'll have already seen this. This will be a plus, which means this is really the formula cosine x, or a minus y, whatever it is. So it's 100 minus 40, which is 60. So this one should be the cosine of 60. This one will be a minus, which means we're going to add them. So this becomes cosine of a plus b. If you like a plus b, if you like x plus y, it doesn't matter. So we're going to add those. So really what we end up with here is cosine of 190 plus 35, which is really the cosine of 225. Reference angle 45 degrees. That's 45 square root of 2 over 2. It's in the third quadrant, so that's negative. And my final answer, thank goodness, I'm tired of this stuff. How many complete cycles of this, will there be in 2 pi? I didn't put the rest of the answer question on there. So what happens is that's really just frequency. How many complete cycles will there be in 2 pi? And there'll be 2 complete cosine curves in 2 pi. So the answer here is just 2. That's it, kids. That's all she wrote. Let me finish off, sign off, peace out. If you like what you see, if you didn't like what you see, sorry I wasn't that entertaining. This is like my 4th video today, and I'm kind of tired. So peace out, kids. Love you to death. Bye.